My name's Mr. Hawkins, and today we're going to be talking about mental math and thinking in tens. And so what this means is that when you have a number, say we have a number like 13, 14, 15, it doesn't matter what it is. We're going to break this number down into a 10 version of itself and a single digit of itself. So by a 10 version, I mean multiples of tens. So with 10, you can think of this number as 10 and 3. So 10 plus 3 is 13, right? With 14, you might have guessed, you can break this number into you can break this number down into 10 and 4. Why did it turn yellow? Hold on. 10 and 4. 10 plus 4 is 14. And with 15, you might have guessed, you could break this number into 10 and 5. Now, how does this help us when dealing with mental math? That might be the question you're asking right now. Oh, perfect. It's showing everything I want. Well, when you multiply by a number, say you multiply 13 by 4 or 5 or 6, doesn't really matter. You can break that number into two pieces because 10 is easy to work with and 3 is relatively easy to work with if you know your basic multiplication tables. So instead of thinking 13 times, let's just say 6, you can think of 13 times 6 is really 6 times 10, which you guys know to be 60. And then you can think of it as 6 times 3. So I can use the little times if you want. 6 times 3 is 18. And now you have 60 and 18. So when you add those together, which is relatively simple, 60 and 10 is 70. 70 and 8 is 78. So you can go back to your 13 times 6 example and be like, oh, it's 60 and 18, 78. So this is what it means by thinking in tens as far as multiplication is concerned. It's a really, really easy concept, but it does require some practice if you're not used to doing it. So let's look at this for 14. So instead, let's say I wanted to do 14, there we go, times 7. Looks a little bit challenging, right? But we're going to apply the same trick. So 14, like I said earlier, is broken into 10 and 4. So 10 times 7 is 70. 10 times 4 is 28. And then you have 70 and 28. Well, just add them together and you get 98. And so 14 times 7 must be 98. I know this is kind of sloppy, but hopefully my videos will get better with time. Let's do a couple more examples. I'm gonna go to a new whiteboard. I know there's a way to do it. Just give me a sec. That's how. Alright, let's say I wanted to do, I'll just pick a random number, 26 times 4. Looks kind of complicated, but if we remember our rule of tens, let's break 26 down into a multiple of 10 and a single digit. So 26 is just 20 plus 6. And then we're going to multiply each of those numbers times 4. So 20 times 4 is, well, 2 times 4 is 8. So 20 times 4 must be 80. And then we're going to say, oh, 4 times 6 must be 24. So now we have 80 plus 24. We just add those numbers up and we get 104. So this is, at least when multiplying, this is the key methodology in thinking about it in tens. You break it down into its 10 component, its 1 component, and then you do each separately in your head. So without writing it out, you might be able to do something like 33 times 4. So without writing it out, let's work through the methodology behind solving it, okay? So 33, we know, is multiple of 10, 30, and then 3. 3 times 4 is 12, so 30 times 4 must be 120. Just add the 0 at the end. And then, you know, 3 times 4 is 12, so we have then 120 plus 12. So we get 132. So 33 times 4 must be 132. No math, or I guess no pencil and paper required. You could also apply this methodology to things with subtraction. Let's talk really quick about the thinking in tens subtraction method. So same idea, except this time we're going to do stuff like 19, 18, 17, and think about it as 20 minus a number, because it's the closest 10 value. So we're still thinking in tens, but now we're going the opposite direction. So let's start with 19. You could think of this as 10 and 9. You could also think of this as 20 minus 1. Now, the reason why you might do this instead of 10 and 9 is because 20 and 1 is really easy to work with. So if I said 19 times 3, you could think, oh, 20 times 3 is 60. 3 times 1 is 3. 60 minus 3 is 57. So 19 times 3 is also 57. Thinking in tens makes mental math easy. Let's move on to thinking in tens with percentages. So that's the second part of this. So percentages. Here, I'm going to try to lower my mouse speed. I have very shaky hands, so sometimes this helps. Let's say I wanted to find a certain percentage of a number. Now, how can I relate this to thinking in tens? Well, it's certainly similar. The tricks are slightly different. Let's say I wanted to find 7% of 22. Now, the thinking in tens part comes not by, you could think of tens in this, but really you want to compare this to 1%. Because once you have something in 1% form, you can find any form. So for the base number 22, you can think of this as 100% of something equals 100% of my total, right? So 10% is really easy to find as well. All you have to do is, well, if this was the decimal, so this was my 100%, here's my decimal, all I have to do is move it. So that becomes my new decimal, and I can erase this part. Boop. And here's my 10%, 2.2. Notice it's still 22, it's just decimals moved over once. Now we're going to do the same thing for 1%. So just move the decimal over one more time. So with 22, all you have to do is move it again. Boop, 22. Now we have a 0. Don't forget the 0 there because it's a placeholder. It's in the ones place. And now 1% of 22 is 0.22. It's just like 100% is 22, 10% is 2.2, and 1% is 0.22. Easy stuff there, right? Now, how does this relate to 7%? Well, if you know what 1% is, you can easily find what 7% is. And thinking about what we just used on thinking about stuff in tens, you can use the same methodology for 22. So you could say, oh, this is 20 and 2, right? So 20 times 7 is 140. So I have 140. And 2 times 7 is 14. So all I have to do is add 140 and 14 and I get 154. Now remember, I had to move my decimal place 2 spaces on the 1%, so I'm going to do the same here. So if 154 is this times 7, then I'm going to move it 2 spaces and I get 1.54. So 7% of 22 must be 1.54. It's all about thinking in tens. It's the same exact methodology we used earlier. Thank you for joining me in this short instructional video. I hope you enjoyed today's activity on the matter. If you have any more questions, you can ask me or message me in the chat on Blackboard. Thank you.